Okay guys, for the second part of this lab, we're going to just carry on from this, and we're going to stop the girl, our skater, at a different point, not just at the bottom, okay? And we're going to use the math, we're going to use the physics equations to predict what speed she's going to be doing. So let me just pull this thing away. I'm just going to let her continue on in her path. And you can feel free to do this at the same time as you're doing the first one if you wish. Okay. So once again, I know that my initial height is the same. So I'll pop this one in here. She's still 60 kgs. The initial height was 3.4 meters, and we calculated the same GPE over here. So that's the same gravitational potential energy as the last time. Now here's where things get slightly different, okay? So we know that the actual GPE from the simulator was a little bit different, so we're not going to worry too much about that. The next thing I'm going to do is I'm just going to run the simulation just ever so slightly longer. So I'm going to let her come down the ramp here just a little bit, maybe around here somewhere. Okay, so again I'll choose a height. I don't need to use my measuring tape. I've got a height of 1.50, and again if I just go to one of those dots, it'll tell me all the details about that particular position. So height number 2 is 1.5 meters. I'm going to calculate the gravitational potential energy at that point. And again, I'm going to use the mathematics to do that. So her gravitational potential energy at point 2 should be mgh. But this is I'm looking at the second height, h2. So she's still 60 kgs. We'll still use 10 newtons per kilogram. If you want, you can switch to 9.8, and then it might match the simulation a little bit better, but it's okay. The height we know is 1.5 meters, so that gives her GPE at point number 2 to be 900 joules. So let me pop that in there. So the kinetic energy now becomes of interest to us. Again, I could use the probe here to find out what it should be, but that's not the point behind this. The point here is to figure out what the kinetic energy will be using the equations, because obviously you're not going to have a simulator in your exam. So to do that, we know that at position number 1, which was back up here, position number 1 was when she started. She only had gravitational potential energy. So that's 1. But at position number 2, she's got both gravitational potential energy plus kinetic energy, because she's also moving at 2. So up here we had mgh. Just to sub in the values, that would h1, that was the initial 3.4 meters. Then we've got mgh2, which was 1.5 meters. I'll just sub in the values in a second. And then we've got a half times the mass times velocity squared. Now at this point, what you should actually be able to see is that you've got a mass on both sides. So if you were doing this carefully, if you want to do this maybe a slightly different way, what you could actually do is factor out the masses on the right hand side and cancel them out completely. But we don't have to, because we've already got these values. So we know that our gravitational potential energy here was 2040 joules. And we know that here we've got 900 joules that we just calculated from down here. And that's equal to a half times the mass times the velocity squared. So I'm going to subtract the 900 from both sides, and that leaves me with 1140 joules of potential kinetic energy. Of kinetic energy. So that's the kinetic energy that I should be putting in here. That's 1140 joules of kinetic energy. But of course we know that the kinetic energy is equal to a half mv squared. So then I want to rearrange for the velocity and predict that. So the velocity is going to be twice that value divided by her mass. So again, the mass cancels out, and take the positive square root of it. So that's going to be the square root of 38, which works out to be, should be just over 6. So that is 6.16 meters per second. So that's my predicted value for her velocity here. And let me put that in here, 6.16 meters per second. And at this point, let me double check the simulator and see, well, what is her actual speed? Oh, and lo and behold, it is 6.16 meters per second. So I've got it right. Okay? So again, that's what I want you to do. I want you to stop her in various heights. And again, you can just go to the next line and come down. Don't change her mass. Leave her at the same initial height, and then just change the second height. So you can just come down here and maybe make that a different value, a different one of those little purple dots, and go from there. Okay? Hopefully that makes sense. So again, just to recap, all you're going to be doing is changing the second height, calculating her second potential energy gravity, leave the first one alone, figure out what's left over in the form of kinetic energy, and then use that to predict her velocity. And then of course just double check using the actual simulator to see what the actual velocity is. Okay, hopefully that makes sense. Let me know if you have any questions.